Okay, so as in the last video, we have discussed about the work example 9.1 in very detail. Alright, initially we wrote the data as data was given in the question, right? They gave us the ER, which is relative permittivity, and they gave us that as 4. Alright, then they gave us the area of the plates as well, and that was 0.01 meter square. They gave us the separation, the distance between the two plates as well, and that they given us as 0.002 meter. Alright, epsilon naught value we were already known because that was a constant, right? So that's value is 8.85 into 10 to the power minus 12 farad per meter. That we were already known about, right? So now we have all the data, we just have put them in our formula, and that was epsilon naught times ER times 8 upon D. Alright, we put them in this formula, and in the end we got the result of 3.5416 into 10 to the power minus 11 farad. That was our capacitance of the capacitor. Alright, in today's video, this is just a numerical which we have discussed in our last class. But in today's video, we are going to solve the multiple choice questions. Alright, so let me go with that. Now this entire chapter is completed, only the multiple choice questions were remaining, right? We can actually go with this as well. This is very easy. Alright, initially we have discussed about capacitor. It is a device which stores large amount of charges in it, right? That is capacitor. Then we have charge storing device. We already know that this is just a thing which I've just told you now, right? Then we have discussed about capacitance. We have discussed about series combination, parallel combination. Alright, here you can see series combination. Wait, series combination, parallel combination. After that, we discuss about the dependencies of the capacitor. We know that capacitor depends upon the area and the distance between two plates. Alright, and because of this, we derived the entire equation that was equal to C is equal to epsilon naught times ER times A per unit distance. Alright, then we discussed each and everything in very detail, and in the end, now we are going to solve the MCQs. Alright, as you can see, we are just going to solve the multiple choice questions today. So the first MCQ is the capacitance of capacitor is not influenced by. What it would be not influenced by? The simple meaning of this question is what the capacitance of capacitor does not depend on. Alright, now let's read the options, right? Plate thickness, we will discuss each and every MCQ, right? So plate thickness, we know that capacitance of a capacitor depends upon the area of the plates, the distance between the plates, and the material of the medium, but it does not depend on the thickness of the plate. Alright, it depends on the area of the plates, it depends upon the plate separation, means distance between the plates, it depends upon the nature of the dielectric as well, which means it does not depend on the plate thickness. Alright, it does not depend on plate thickness, however it depends on the area of the plates, the distance between the two plates, and the nature of the medium which is present between the plates. Alright, in the second question, as you can see, what's the second question is about, what is the value of capacitance of a capacitor? They are asking us to find the capacitance of a capacitor which has a voltage 4 volt and 16 capacitor of charge, 16 coulomb of charge. Alright, so 4 volt they have given us, and they have given us charge which is 16 coulomb. We need to find the capacitance of a capacitor, and there we have already driven the entire equation, right? The charge stored on the plate of the capacitor would be directly proportional to the voltage provided to it. When we remove this proportionality sign, we have got is equal to C is equal to V. Now we need to, this is basically charge, sorry. So we need to find the C. So C is equal to Q per unit V. Q is 16 coulomb per unit. Voltage is 4 coulomb. So 4 ones are 4 fours are. So 4 farad would be the capacitance of the capacitor, right? What would be it? It would be 4 farad. Wait. So let's 4 farad, right? We have discussed now how did we get this 4 farad. We just got this because of the formula, which is charge is directly proportional. Charge stored on the plate of the capacitor would be directly proportional to the potential difference provided to it. Alright, then we remove proportionality sign, we got is equal to C. We need to find C, so voltage was multiplying with the C. When it had gone there, it would be divided with the Q, right? So C is equal to Q per unit V, and Q is 16, V is 4. So 4 ones are 4 is the 16. Thus, we got 4 farad as the capacitance of a capacitor. The third is capacitors are used in electric power supply system to provide voltage stability. To provide voltage stability. Alright. I don't think here we have something to describe about, or I need to here define everything out that how the C option is correct. But yeah, it is understandable, right? In the fourth option, in a variable capacitor, capacitance can be varied by turning the rotatable plate. The theory we have already read about, right? We have discussed about the 4 different types of capacitors: the variable capacitor, ceramic capacitor, film capacitor, electrolytic capacitor. We have already discussed about. Alright, then they are asking about energy stored in the capacitor is, this would be 1 upon 2 CV square, right? This we already know. Instead of M, we're gonna write C. We have already discussed this about. Alright, now they are asking the time constant of series RC circuit consisting. This is the C. We have 100 microfarad capacitor in series with 100 ohm. They have given us resistance plus capacitance. We need to find the time constant, and we know that RC is also known as time constant. Alright, they have given us R, they have given us C. We need to find the time constant RC. So R they have given us 100, right? 100 ohm, and capacitance they have given us 100 micro. 100, wait, 100 micro. Micro means 10 power minus 6, right? So now this is 1 2, so 1 into 10 to the power minus 4, because 2 points have been moved, right? So 1 into 10 to the power minus 4, right? Again 1 2, so this would be 1 into 10 to the power minus 2, which means 0 0.01 1 2, right? So the answer would be 0.01 second, because this is time constant. Alright, so let me remove it out. I hope this is very much clear to you now. Since RC is the time constant, that's why the unit of it would be basically second, right? Okay, let's discuss about 7th MCQ. The charging of a capacitor through a resistance follows exponential law. Very easy, alright. Again, the 8th one, when the total charge in a capacitor is doubled, the energy stored. Now see, if the charge is doubling here, right, means the energy will be doubled as well, because E is equal to 1 upon 2 CV square when we get the C, because we know that C is basically the ratio between the charge stored on the plate of the capacitor and potential difference provided to it. So 1 upon 2 uh, Q over V into V square. 1 V cancelled with 1 V, so E is equal to basically 1 upon 2 QV, which means energy is directly proportional to the Q. If you are doubling the charges, the energy would automatically be doubled as well, which means if the total charges in a capacitor is doubled, the energy would be doubled as well. Alright, now the 9th one. The capacitance C is charged through a resistor. We know that time constant is RC. It is the product of resistance and capacitance, which is known as time constant, and the unit of time constant is second. Alright, last but not the least MCQ is capacitors block. We already know capacitors always block direct current, and they always allow the alternating current. So if they are asking you in the MCQ what the capacitor allow, they allow the alternating current or AC. What do not allow is direct current, the DC. Alright, so in today's video we have solved our all MCQs as well. very easily with explanation how the answers came. All right, in the next video we're going to start our new chapter of physics.